Hello everyone. This is going to be this last chance or last stab from me to get you to resit for an exam which was you were given the questions and the answers early, and the goal was to establish some sense of knowledge so that as you build through the rest of your classes you have something that you can check besides the tangent of 45 is equal to 1. That said, sitting down to any engineering exam, survey exam, whatever, you need to probably start to learn to know what you know. And so one of the things we tried to get you all to know is at very least, and then even more than that, that on the circle here that you have at pi over 3, at pi over 4, and at pi over 6, you have some values that you should know. And those turned out to be, if you remember, the first value of this would be less than the second value. So for pi over 3, the cosine was 1/2, and the sine is the square root of 3 over 2. And you have to know then the tangent becomes the square root of 3 because this emerges in the top or the bottom. For pi over 4, we have the square root of 2 over 2, the square root of 2 over 2, and we all know the tangent of 45 degrees is 1. And then for pi over 6, which is 30 degrees, it's the reverse of the 60 degrees, so it's the square root of 3 over 2 and 1/2 and 1 over the square root of 3 for the tangent. So these three values being the tangent. Realizing as well, many of us believe that pi over 12 is greatly underlooked, considering every 15 degrees gets you a lot more than just a couple of holes in your circle, and that one either using the half angle approximation or just learning by brute force or putting in your calculator 0.9659 and then 0.2588, and the tangent you then have to calculate it as sine over cosine. That said, when you're doing trig problems, the other thing you need to then do is to realize to get what quadrant it is or how many revolutions it is by either dividing by 180, 360, or whatever you're going to do, 90 if you would, and then figuring its value by how far away it is from the axis. So that said, we're going to go through these problems now. The sine in 90 degrees, which would be the second value, is in fact sine of 90 degrees equals the second value up here, and so that was equal to 1. Going down to the next problem, the cosine of 225. Well, cosine of 225, you have to identify what quadrant it is. If you divide by 180 and take the remainder, you have 45, so it's in the third quadrant, and it's 45 degrees. So it's the square root of 2 over 2, but you have to go back to all state technical college or all seniors take chemistry and realize it's a cosine of 225 is a negative square root of 2 over 2. Look, it's not just the tangent of 45 you need to know the other ones as well, the full circle. The cosine of 30 degrees. Cosine of 30 degrees is in fact going to be more in the x than it is in the y. The cosine is in fact the same as the cosine of pi over 6, so it is the square root of 3 over 2 in the first quadrant. The cosine of 15 degrees is the same. The cosine of 15 degrees is the same as the sine of 75 degrees because of symmetry about the 45 degree y equals x line. The cosine of 5/3 pi, I'm going to go do one more and then I'll switch the screen. Well, then the cosine of 5/3 pi is 1/3 pi less than a full revolution. So it is the same as pi over 3, and it is positive. All seniors take chemistry. Pi over 3, the cosine is 1/2. So this would be cosine of 5/3 is equal to all seniors take chemistry, right? It is 1/3 less than 6/3 pi, Therefore, it's the same as pi over 3's cosine, and it is in fact a half. I'm going to go to a new slide here, see how we do on that one, if it gets any better. Try to erase that. Alright, I'm going to go back to here, just zoom down the page, I guess. Let's move around here, I guess. Alright, so sines and cosines, you identify the quadrant. Tangent of 8/6 pi. Well, once again, 6/6 pi, that's 6/6 pi is pi. 2/6 more is a third pi. A third pi is you're looking at the tangent of pi over 3 in the third quadrant. All seniors take. And so it's a positive. The tangent of 8/6 pi is a positive 1. We'll continue quicker now. The sine of 7.5 pi, when you get above 2 pi, you divide the 2 pi out and take what's left over from any even division. It's called actually the modulus. The modulus of 7.5 pi divided by 2 pi will get you the fact that this is 3/4 of the way around again. So this is sine of 7.5 pi is the same as the sine of 1.5 pi, which of course is -1. Keep going down through. The tangent of pi is the tangent of 0. Therefore, the tangent of pi is 0. Because the tangent is 0, tangent of a small angle is the small angle. Tangent of pi equals 0. The tangent of pi over 100 is a small angle approximation. It is pi over 100. The sine of the angle 101 over 100, you have to break that down into quadrant and then the angle. The angle is 1/100th pi. So the value you get is 1/100th pi. It is in the third quadrant. And so the third quadrant, all seniors take chemistry, it would be a negative value. This is the sine of 101 over 100 pi. So do not let trigonometric functions that are greater than pi over 2 or pi or 2 pi throw you. Just take what's called the modulus. The modulus of a number is the remainder, if you would, when you do the division by 2 pi. Okay, now we're into this discussion, and I'll try to now see if I can go to a new screen here. I don't know that it's going to work. But this concept of starting around the circle from specific gravity, radians, distance, area, volume, mass, force, work, power, pressure, torque, density, and unit weight. And remembering there are 13, I might say 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Unit weight is across from specific gravity. And if you lay that in with the mass being slugs and kilograms, the force being newtons and pounds, the work being watts and foot-pounds, the pressure being pascals and pounds per square foot, the torque being newton meters or pound feet, the density being slugs per cubic foot or kilograms per cubic meter, and the unit weight being newtons per cubic meter or pounds per cubic foot, then you should be okay with any of the other questions regarding units. So number 11, the units of mass in the imperial system are slugs. The standard units of power in the metric system are watts. How many standard gallons are there in a cubic foot? There's all kinds of different ways to do that, but knowledge would be one of them. Another one would be knowing that a gallon weighs 8.34 pounds, but there are 7.48 gallons in a cubic foot of water. Moment of inertia is a concept that you have not done much with, but you know that kilograms must convert to slugs and square meters must convert to square feet. So knowing the base units lets you get more complex units without having to look or spend time on what should be knowledge, which is conversion of, or knowledge of anything directly descended from base units. How long is a rod in a 4-rod road? A rod is 16.5 feet, because a 4-rod road is a 66-foot wide right-of-way. 1 kilogram is the same as 9.8 newtons, which is the same as 2.205 pounds. So beyond that circle, you must know some of the other things. So 2.205 pounds is 9.8 newtons. Going down through, a horsepower is the same. Keep going through here, see if we can move around on this document. Home, new slide. Bring the right slide here this time. A blank slide, how's that for a concept? All right, here we go. So 1 horsepower, you should know, is 746 watts. And I think most of you have that one. That's one you've chose to know. Equals 1 horsepower, which is the same as 550 foot-pounds per second. 90 miles an hour is the same as 1.5 times 60 miles an hour, or 88 feet per second times 1.5. So I think that turned out to be something like 132 feet per second. Remember, now we've gone up to this more or less 100 feet per second is around 68 miles per hour. We have to know that 100 feet per second equals 68 miles an hour is exact. However, we also need to know that some of the other values, how we use this, are more important than necessarily those exact numbers sometimes, as long as we know that they're there. How many milligrams in a liter of water? 1 liter is 1,000 grams. 1,000 grams equals 1,000 milligrams equals 1 gram. Therefore, there are 1 times 10 to the 6th, they're 1 million milligrams per liter. That's the same as a part per million. The weight of 1 cubic water, 1 cubic meter of water is 1,000, and I'm going to go with it. It's the weight. So the key words here is the underlying weight. The weight of 1 cubic meter is 9,800 newtons, not the mass, the weight. 21, centripetal force. You have to know centripetal force is mass times acceleration, which is mass times v squared over r for centripetal acceleration. You've now done that in super elevation. 22, a 3-inch internal diameter pipe. 3 compares to 24, 8 times, pi is always there, pi over 64 square feet. You can calculate it out by any other way you want, but that does work. You compare and square, the pi is always there. 3 is less than 24, so it goes in the bottom. Cross-sectional area of a 60-inch internal diameter pipe. That one's a little tougher because it's 2.5 times, so you got to take 2.5 and square it times pi. The pi is always there. However you want to calc those, you're free to do it by hand as well, but this does work and it keeps things in square feet. How many meters will a free-falling object fall if it's dropped from a very tall building? You know that velocity after 3 meters is 30 meters per second. The average, the V bar, is 15 meters per second. So how far? 45 meters. The average angular velocity problem is exactly the same. It begins over 3 seconds. It goes from 0 up to 6. Therefore, its average was 3. It was traveling for 3 seconds, but its average velocity is 3 radians per second. So that is a question of velocity, not necessarily angular displacement. How many degrees of freedom does a baseball have? It has X, Y, Z, rotation about the X, rotation about the Y, rotation about the Z. So 6. How many survey inches in a meter? 39.37. Standard units of pressure, pascals. And the metric and SI are the same. That's not meant to be confused. SI is System International. You need to recognize both. The most correct one is actually SI, not metric. Standard units of pressure in the imperial, pounds per square foot. Soil pressure 5 inches deep in dense dry sand would be something like what? Gamma times depth. When gamma in this case is the soil, so it would be in the order of about 110 times 5, or around 550 pounds per square foot. That idea of depth times unit weight comes up a lot in fluids as well. In KSI, what is the approximate stiffness of steel? And we're back. The approximate stiffness of steel. Remember that stiffness and strength are not the same thing. The stiffness of steel is actually around 30 times 10 to the 6th psi, or about 30,000 ksi. I probably actually even misread and misgraded that. So what is the approximate specific gravity of cement grain? 3.15. We'll go back to a couple of these at the very end. The back azimuth is the 340 plus or minus plus 2 minus 2. So if you minus 2 from the first, you get 1. Add 2, 160, which would make sense for 340. 3 CFS for 1 day will generate 6 acre-feet. 4 milliradians at a foresight distance. This is an S equals R theta. Trying to go through here and see if I can get this so I can see it again. S equals R theta, which I'm not going to do. Go back to home here, new slide, see how we're doing. Okay, S equals R theta. A milliradian is in fact 1,000th of a radian. And so you take a milliradian, you have the R equal to 2,000 meters, and the milliradian is 0.004. You get, in this case, 8 meters. But you should know 1 milliradian at 1,000 meters is a meter off in terms of arc length. Constant force problem. I do believe that the best definition for force is the change in momentum over the change in time. You can think of the same as this is acceleration. And so we have a change in momentum going from 20,000 to 0 over 3. So the answer was 20,000 divided by 3, or about 6,666 newtons of force on average. Going down through, slope. Slope is derivative. Area is integral. And you must keep track of units. The area under a hydrograph, if it is feet cubed per second, and this is seconds over 1, it is cubic feet under a hydrograph. You must be able to interpret areas under curves and the units as well for many, many things, including stress strain, hydrographs, load curves, and thinking it as separate problems as opposed to just basic applied mathematics will get you into trouble. Planar survey is left. So planar survey is northings, eastings, it's left. Everything else is right. GPS is right. Normal weight of concrete, 150 pounds per cubic foot is what a design number is, but you know that goes up from there or down from there based on air. Speed of light, C is 2.9979 times 10 to the 8th meters per second, or 186,000 miles per second. However, learn 2.9979 as you've taken a GPS class and used it on a regular basis. Speed of sound is 340 meters per second, 5 seconds for a mile if you're out golfing. Capacity of a 4-foot diameter pipe flowing full. You take the area times the velocity of 10. So the area is 4 pi times 10. That would be 40 pi cubic feet per second. Porosity of soil. Try this again. Home. This actually problem is a pretty straightforward, easy problem if you visualize with definition. The definition of void ratio is 0.8. So you have this. This is the volume of the solids. The volume of the voids. This is 0.8. This is 1. So the volume total is 1.8. So in fact, the void ratio would be, the porosity would be 0.8 over 1.8. That is not a difficult problem. You do not need to go deep into the soil weight volume chart, but knowing that soil weight volume chart is something that I will summarize very quickly in the next short video, which accompanies this one, which kind of gives you a heads up on the pictures that you might carry forward to get to this 390 or 360 facts. Almost finished. About 25%, around 25% is a typical moisture content out around for saturated material out near us. It can vary, of course. Definition of the inverse of a number of matrix is the number you multiply by, multiply by to get 1. So that's a really important thing for many, many, many things. For transformations, for math, and for, as you saw, for solving simultaneous equations. Almost done here with the 50 questions. 60-degree angle, you're looking at the slope, therefore you want the tangent. The tangent of the angle is the slope, and so you want the tangent of 60 degrees, which you should start to know is the square root of 3. Because the square root of 3 emerges either on the top or the bottom on your standard 30 and 60. You can think about the triangles if you want, but the reality is the unit circle does do most of what the triangle trig does for you. Slope of a line perpendicular to 1/2 is going to be the negative reciprocal, so -2. Mohr's circle of stress, finally, was on the x was axial, and on the y was shear. And finally, anytime you build a road, you build a river, a dam, and or a lake. All right, that's 25 minutes, but you can have gone through these and see which ones you know. The answers are all there for one more time. I will put the pictures all together in an accompanying video and push this out. I apologize for the format, but within 1 hour, then you should be able to watch this, sit down, and do relatively well on a set of questions and answers. And so you can bring up those scores of 30 and 40 up to what was the intent, and that was 100% for everyone on this exam. Thanks for listening.